Let's do another recursive example. We'll look at the factorial operation in math. And the factorial is an application that gives you the product of all of the positive integers between some given number and 1. So I'll create a factorial project and we'll take a look at how to do this. So let's consider what a factorial is before we start here. If I take factorial 6, that's equal to 6 times 5 times 4 times 3 times 2 times 1. Similarly, 5 factorial is equal to 5 times 4, etc. So if you remember from our previous example where we were doing powers, you can start to see the pattern here, where in fact 6 factorial is actually 6 times 5 factorial. And here again we have recursion. We are calling the factorial of some number in the process of trying to determine the factorial of another number. So a factorial solution involves calling the factorial method again. And similarly, we can think of 5 factorial as being 5 times 4 factorial. So we can see that pattern now. One of the ways to help us determine our base cases is to start small. Now, it just so happens that with factorials, 0 factorial, even though there is no 1, 2, 3 between 0 and itself, it turns out that the factorial of 0 is always 1. 1 factorial is also always 1. So 2 factorial is going to be equal to 2 times 1. And if we look at the other examples, we can see that, well, 1 factorial is also equal to 1. So I could think of this as 2 times 1 is 2 times 1 factorial. And I could start my recursion with 2. So I can think of all of these as base cases. And I can think of everything from 2 and higher as being the start of my recursive cases. So if I'm calculating the factorial of 0 or 1, it's a base case and I'm just going to return the number 1. If I'm calculating the factorial of 2 or higher, I'm going to return the value that was passed in this case 2, times the factorial of a number that's 1 less than what was passed in. So some other examples, and so on. So let's take a look at how we code this. Now you'll notice I have an integer that's passed in as the number I want to take the factorial of, but I'm returning a long, and that's because factorials can get really large really quickly. So even though I might want to accept only integer numbers in a smaller range, the factorial of those numbers can get much larger, so I'm going to want to return a long. Let's start with our base cases. And next our recursive cases. And that's it. That's a recursive factorial algorithm. So let's check it out. Okay, so this is going to print out all the factorials from, well, let's make it 0 to 20. I'll put an equal sign here. And I keep forgetting to declare my static methods as static. Okay, so we're going to call this factorial with all the numbers from 0 to 20, and it's going to print out the factorial values. Let's check it out. Okay, so starting at the beginning, the first one is for 0, and that's going to be 1. The second one is for 1, that's going to be 1. The third one is 2 times 1, that makes sense. The next one is 3 times 2 times 1, which is 6. And then the next one is 4 times 3 times 2 times 1, which is 24. So we can see that it's working properly, and by the time we get to 20, we have an enormously large number. And that's it, a recursive method for calculating factorials.